We're going to talk about system of equations. First, we're going to talk about linear equations. Then we're going to expand the idea to non-linear equations. So for example, when we're talking about linear equations and a system of linear equations, we usually have two lines like 2x plus y equals to 5, and another line 3x minus 2y equals to 4. This is an example of system of linear equations. We have two lines, line 1 and then line 2. When you're talking about system of nonlinear equations, you might end up seeing something like this. Y is equal to x cubed minus 3x squared plus 2, and y equals to x squared minus 3x plus 1. These two are non-linear equations. So we have a system of non-linear equations. When you're writing system of linear equations or non-linear equations this way, it means that we are trying to find the intersection between them. So this is the goal. We are trying to find the intersection between these graphs. Again, we are trying to find the intersection between these graphs. So when I ask you to solve a system of equations, either linear or non-linear equations, I'm asking you to find the intersection between these two lines, also find the intersection between these two graphs. So let us take a look at Desmos, see what do we have. Let's take a look at Desmos. Here, graphing calculator, and the very first line is 2x plus y equals to 5, and the second line is 3x minus 2y equals to 4. So as you can see, these two lines are intersecting at this point. At point x equals to 2 and y equals to 1, you have one intersection. So this is geometric solution, but we need to be able to solve it algebraically as well. So by using Desmos, we were able to saw that there is a solution here. Now algebraically, how do we solve this system? We need to do the algebra. What we can do here, you can say that, hey, I have 2x plus y equals to 5, and I saw 3x minus 2y equals to 4. For a moment, if you add these two equations, add these two equations, what you see is you see 2x plus 3x plus y minus 2y equals to 5 plus 4. So you're adding left-hand side together, you're adding right-hand side together. Just take a look at this. I have 5x minus y equals to 9. It created a new equation for me that has two variables. I don't want this. This is not what I'm looking for. I try to add these two equations and get rid of one of the variables. First, multiply the first equation by 2. So take a look at this. I have 2 times 2, which is 4x, plus 2 times y, 2y equals to 5 times 2, 10. This is my first equation. Copy down the second equation. 3x minus 2y equals to 4. Now start adding these two equations together. Add them. What do you get? You get 4x plus 3x plus 2y minus 2y equals to 14. Hey, take a look at this. 2y minus 2y is 0. It just disappears. So what do I have? I have 7x equals to 14 or x equals to 2. I found my x value. Now you can either use the first equation or second equation to find your y value. So let me use a different color. Use one of these equations. It doesn't matter which one, line 1 or line 2. It's not important. Suppose I take line 1. If I take line 1 and substitute 2, I get 2 times 2 plus y equals to 5, or 4 plus y equals to 5, or y is 1. Hey, this is the exact same point I saw using Desmos, all right? Let's go back to take a look at Desmos. Desmos graphed these two, and then it showed the intersection at 2 and 1. I did the algebra, and algebra verified that these two lines intersect at this point. X equals to 2 and y equals to 1.